Hi, I'm Aditya. I'm the team lead for Hindustan Mars Rover Team. This time, we have implemented a rocker-link suspension system. This hybrid design enables the rover to traverse over all extreme terrain, keeping the reliability of the system high while exploiting the advantage of high dynamics. The chassis is a single-layer, interconnected network of members, which is designed to structurally support the entire rover while taking space constraints into consideration. Aluminium 6061 has been preferred material throughout the fabrication of the rover, with the exception of a few steel parts wherever deemed necessary. Requirement constraints were set as boundary conditions and each component was designed accordingly. Finite element analysis, bending stress analysis, impact tests of component prototypes were carried out in order to determine the feasibility of design and material.
Hi, I'm Alan Frederick, the Administrative Team Manager of the Hindustan Mars Rover Team. Each rocker has an innovative mechanical rotation limiter built into the system. This restricts the motion of the rocker to a rotation of 90 degrees, thereby ensuring the suspension system does not exceed its design limit, preventing dynamic instability in the rover. We have designed a 5DOF robotic arm. It has a base yaw motion, 2 pitch freedoms, 1 linear motion and 1 roll degree of freedom. Using kinematic equation, we derived the inverse kinematics of the robotic arm. The results were integrated into our software system that enabled us to make the entire robotic arm purely autonomous.
Hi, I'm Abhishek, Technical Team Manager. The rover is powered by two 10,000 mAh LiPo batteries. It is controlled by two Arduino Mega and Raspberry Pi. The communication is done via Rocket M2 transceiver, uses Wi-Fi as its medium of data transfer. All system on board the rover is integrated as closed-loop control system.
Running completely on the robotic operating system and having the freedom to customize the OS, it serves as the ideal platform on which the rover software system was built. The instrument display panel is based on an aviation-inspired layout. The GUI layout is made in such a way that every aspect of the feedback system is easy to view as clubbed in a specified area. The GUI is built using Qt framework, which runs with ROS. The communication between the microcontroller and the GUI is done using Q-string data transmission.
The rover is controlled using an Arduino microcontroller. Its acceleration is monitored using rotary encoders which give out data in terms of radial coordinates. LM35 sensors are integrated as part of a condition monitoring system which maintains ideal internal temperatures. We have designed the current flow monitoring circuit which monitors the current flowing in and out of the circuit.
Onboard instruments such as pH, electrical conductivity, thermal sensor and moisture content probes are attached to the end of the robotic arm which are used to analyze soil properties. Reduction reactions such as sodium borohydride and oxidation reactions using potassium permanganate are carried out.
The soil sample is treated with furan reductum and the sulfur is reduced to sulfide. Sulfide is treated with acid and then evolved sulfide is estimated iodometrically with standard alkaline hypochlorite solution which acts as the absorbent, and the absorbent gives us the proof of sulfur in the soil.
We have used around 50% of our prototype sponsorship to fabricate the suspension system. The robotic arm displayed previously is a prototype that we use to simulate and study inverse kinematic equations for the robotic arm. Addressing the financial concerns raised by the judges during the team proposal feedback, we are glad to inform you that we have been partially sponsored by an Indian startup by the name of Revamped Group. Initial kickstarting financial support was provided to us by the university. The lack thereof of the remaining amount necessary to purchase all components drives us to conduct outreach programs in different schools and universities, giving students a fresh outlook on the possibilities of space exploration and the applications of robotics in the same. More sponsorship opportunities have opened the doors to us and are awaiting confirmation regarding the same. Regardless of all obstacles that the team has faced in the past few months, the morale of the team has always been high, and the drive to contribute and perfect the production of the rover and win the competition grows every single day. I've sectioned this part of the video to detail the grievances that we faced leading up to the deadline of the critical design review. The Hindustan Mars Rover team is based in Chennai, Tamil Nadu, which has been subject to a number of disruptive events. The death of the state's chief minister, a cataclysmic cyclone that tore apart the city, political unrest, and a statewide protest in support of a traditional bull taming sport, which led to curfews, government-instituted holidays, consequentially postponing our university exams, which led to a disruption in our planned schedule by around 30 days. This has mainly affected our production phase, wherein all international purchases and fabrication could not be completed on time. In order to account for this delay and to engineer a rover without compromising on the final quality, the testing phase was shortened. To account for the errors that may arise, more emphasis was placed on the design phase. Extensive FEA, stress analysis and crash test simulation were all performed to ensure rigidity, feasibility and efficiency of the design.